Let's see how to get started with PHP development using Docker containers. I'm going to use Ubuntu in this video, but since what we're really going to use is Docker, it is going to be relevant if you're using either Windows, Linux or Mac OS. Anyway, let's get started by installing Docker. So let's open the terminal. And first I want to update my system. And now that we're up to date, let's go ahead and install Docker. I'm going to use the snap Docker installation. Great, and Docker was successfully installed. The next thing we're going to do is to create a Docker group and add our user to this group. This way we will be able to interact with Docker without using sudo. And our user was added to the Docker group. Let's now restart the computer for the group changes to take effect. And the computer was restarted. Let's open the terminal again. And let's now make sure that Docker was installed correctly by running the Hello World container. And the Hello World image is being downloaded, and then a container of this image will be ran, and it was just ran. And you can see over here, hello from Docker, which means that Docker was installed correctly, the Hello World image was downloaded, and the container of this image was ran successfully. Now that we have Docker installed, it's time to download the PHP Docker image. I'm going to use PHP 8.1, so that's the image I'll download. And the PHP Docker image is being downloaded. And if we now run docker image ls, we can see that we now have two images, PHP version 8.1 and the latest version of the Hello World image. So now that we have this image, we can run a container that's based on this image. So docker run, and then the name of the image that we're going to use. In our case, PHP 8.1. Another thing I'm going to add to this command is the -it flag. And what this is going to do is allow us to interact with the container directly. So let's run the command. And we got access to a PHP interactive shell within the new container. Here we can run simple PHP commands. So let's, as an example, define a variable and try to use it. And we got 9, which is the expected result. But what if we want to run entire PHP scripts? So first, let's close the PHP interactive shell. And you can see that not only the PHP shell was closed, but also the Docker container itself. And we're now interacting with our host machine. So what we're going to do now is run a new container, and we're going to use the same command we used before. But this time, instead of the PHP shell, I want the new container to just run bash. This way, we will be able to run in the container whatever we want. So for the container to run bash, I'm going to specify bash after the name of the image. So space and then bash. And let's run the new container. And we're now interacting with the new container as the root user. Now I want to write a simple PHP program within this container. So let's update the container. And now I'm going to install nano on the container, which is a simple text editor. If we list the files now, we can see all of the files and folders we have on the root of this container. Here I'm going to create my PHP program using nano. And here I'm going to write a simple PHP program that defines a variable and then multiplies it by 3. And let's save the program with Ctrl S and exit with Ctrl X. Let's list the files once again. And here we can see the example.php file, which is the file we just created using Nano. Let's now run this file using PHP. So PHP and then the name of the file. And we got the expected result, which means that PHP works just fine within this container. The thing is that the file we just created is only available within this specific container and won't be persistent across containers. So if I now close this specific container and start a new container with the same command I used before, we now have a different container. And here, if we list the files, we don't have our example.php file, which means that the code we wrote is lost. So what we probably want to have is programs that are persistent across different containers. So let's exit this container. And now I want to create my program on the file system of the host. So I'm going to create a PHP workspace folder on my host. And within this folder, I want to create my PHP program. So let's save the file and exit. And notice that the file we just created is within the file system of the host, of the Ubuntu system, and not any specific Docker container. Let's now run a new container the same way we did it before. But this time I'm going to add another flag, the -v flag. This flag stands for volume, and it allows us to access a folder that's within the host from within the container. So first we need to specify the folder we want to access. And then colon. And then the name of the folder within the container that will be linked to this folder. So let's say root and then php-ws. Now notice that by default, the container won't have a folder called php-ws within its root folder. But the -v flag will take care of it and create the folder for us. So let's run this container. And once again, we're interacting with a new container. And if we list the files now, we can see that we now have a php-ws folder over here. Let's enter this folder. And let's list the files. And here we have our PHP file, which actually resides on the host file system. We can, of course, run this program using PHP. And the good thing about this setup is that every changes we'll make on the source file will be reflected to both the host and to any new containers we will create later on. But what if we want to start the program as soon as the container starts, instead of starting it manually from within the container? So let's exit this container and let's create a new container. But this time, instead of starting bash, we want to start PHP, which will run our example.php file. So let's delete bash and replace it with PHP and then the name of the file we want to run. And if we run this container, we can see that the container started, ran the program, and immediately exited. Let's run another container in the same way. And we can see that our program ran once again. And let's try it again. And the program ran again within a new container.